advancing mathematical genesis toward a theory of computational spacetime formation. Abstract. This paper presents a speculative but scientifically coherent model for how matter, energy, and spacetime events could be generated from pure mathematical computation. Drawing on principles from quantum field theory, information theory, and mathematical physics, the framework suggests that every physical object corresponds to a realizable informational structure. If these structures can be represented and manipulated with perfect precision, mathematics itself could become a tool for constructing physical reality. The approach, termed computational spacetime synthesis, describes how discrete informational blocks could instantiate matter through quantum coherence, entanglement, and topology. 1. The mathematical essence of matter. Modern physics reveals that matter is not a static substance, but a configuration of quantized fields, structured patterns of energy described by mathematics. Every particle corresponds to a wavefunction, psi x t, governed by the Schrödinger or Dirac equations. Thus, the essence of matter lies not in material substance, but in form, specifically the mathematical relations that define its quantum state. This leads to a fundamental equivalence: text, matter, left-right arrow, text, structure, left-right arrow, mathematics. Under this view, to create matter is to instantiate structure. To instantiate structure is to compute mathematics. The act of materialization becomes a computational problem, not a mechanical one. Distributed cluster algebra and quantum computation. Consider a mathematical system capable of describing the evolution of physical states across discrete informational clusters, a form of distributed cluster algebra. In quantum computing, a similar principle exists. A quantum register stores superpositions of states, and operations on those states are governed by linear algebraic transformations in Hilbert space. The universe itself can be modeled as a distributed quantum network in which local patches of spacetime correspond to computational nodes. Each node evolves according to a transition rule. St plus 1 equals RST, where St is the quantum informational state at time t, and R is the dynamical rule analogous to the physical laws. In this context, the emergence of matter is the result of distributed computation acting upon the informational substrate of spacetime. 3. Creating spacetime events through calculation. If every physical configuration corresponds to a solution of the universal equation, RST equals St plus 1, then one could, in principle, construct a specific spacetime event by generating the correct mathematical model of it. In quantum field theory, every possible configuration of matter and energy exists as a quantum amplitude within the total wavefunction of the universe. The probability of a given configuration arising is determined by the squared modulus of its amplitude. P equals big, Langle, psi text target, psi text universe, wrangle, big 2. Thus, if a computation could isolate and amplify the amplitude corresponding to a specific configuration, it could theoretically induce that configuration to manifest, not by creating new matter ex nihilo, but by selectively actualizing a quantum possibility already implicit in the total wave function. This is the foundation of computational spacetime synthesis, the realization of quantum events through mathematical precision. Number 4. Discrete information transfer and quantum coherence. All matter and energy transitions are subject to conservation laws and quantum coherence constraints. To transfer a quantum configuration from one possible state to another, the process must preserve unitarity. U dagger, U equals I. This ensures that information is never lost or destroyed, only transformed. If we consider each spacetime region as a discrete block of informational density, then matter creation can be described as the reconfiguration of these blocks through unitary transformation. Each block of information represents a coherent quantum cluster whose state encodes position, momentum, and entanglement data. By calculating and manipulating these informational clusters, one could, at least theoretically, transfer structured reality between quantum configurations. This corresponds to block-level quantum computation at cosmological scale, where information becomes the operative element of creation. 5. Quantum basecodes and mathematical invariance. For any mathematical model to produce consistent physical results, it must remain invariant under transformation across all reference frames. In physics, these invariants are fundamental constants such as c, g, and h bar. values that hold true in all universes or coordinate systems. A base code numeral system can be defined to represent such invariance symbolically. These are not arbitrary numbers, but dimensionless ratios. Quantities like the fine structure constant, alpha, which expresses the strength of electromagnetic interaction. Alpha equals frac 4 pi epsilon 0 och bar c approx 137. A mathematics built upon such invariance could, in theory, describe reality in any possible universe. These constants serve as the universal alphabet of physical law, the digits of reality's computation. 6. Organic computation and physical information processing. Conventional digital computers cannot yet perform computations that influence the physical substrate of reality because their operations are classical and discrete. They manipulate symbolic representations of information rather than the physical information itself. However, natural systems, such as molecules, cells, and ecosystems, already perform organic computation, processing physical information directly through chemical and quantum mechanical interactions. In this sense, organic computation refers not to consciousness, but to self-organizing physical processes that compute through their own dynamics. Molecular folding, biochemical signaling, and photosynthetic energy transfer all involve quantum coherent events that transform and transmit information with extraordinary efficiency. These systems demonstrate that computation can occur within matter itself without any symbolic programming or awareness. The study of quantum biology explores how such coherence and entanglement enhance the efficiency of natural processes. For example, excitonic transport in photosynthetic complexes and olfactory detection mechanisms exhibit quantum effects that classical models cannot fully explain. These examples illustrate that the universe already performs computation at every level of physical organization. Information is continually being processed, transferred, and reconfigured. From this perspective, the evolution of complex systems, including life, can be viewed as a form of physical information processing in which structure and function emerge from the recursive dynamics of matter and energy. Computation, therefore, is not an abstract metaphor for life, but a measurable activity of the natural world, grounded in the laws of thermodynamics and quantum mechanics. Number 7. Properties of mathematically generated matter. If matter were ever to be generated through computational synthesis, it would exhibit unique physical properties determined by the nature of its informational construction. Such matter would likely 1. Exhibit enhanced quantum coherence, resisting decoherence due to its perfect mathematical symmetry. 2. Display temporal stability, being less susceptible to retrocausal or entropic decay. 3. Possess topological protection, similar to that seen in quantum Hall states or topological insulators, where certain configurations cannot be destroyed without breaking the underlying mathematical structure. In effect, this form of matter would be algorithmically stable, its existence maintained by the invariance of its generating equations. Number 8. Mathematical energy and information dynamics. From the standpoint of energy equivalence, information itself carries energy. According to Landauer's principle, erasing a single bit of information requires an energy of E text PBT En2. This implies that the act of computation is not metaphysical but physical. Every calculation rearranges energy. Therefore, large-scale or high-precision computations could, in principle, reorganize the distribution of energy and matter in the universe. In quantum mechanics, this is reflected in the relation between information entropy and spacetime geometry. The Ryu-Takayanagi formula shows that entanglement entropy is proportional to the area of a spacetime surface, suggesting that the flow of information defines curvature itself. Thus, computation becomes indistinguishable from gravitation. Both are manifestations of changing informational topology. 9. Conclusion. Mathematics as ontological process. The framework of computational spacetime synthesis extends Einstein's insight that energy and mass are equivalent by adding a third term to the triad, E, left-right arrow, M, left-right arrow, I. Energy, matter, and information are aspects of a single, deeper reality, a continuous computational field. Mathematics is not merely a human language describing this field. It is the field. Every equation expresses a real transformation in the structure of being. If future physics succeeds in unifying quantum information theory with general relativity, then it may become possible to compute reality directly, to use mathematics not only to model the world, but to instantiate it. At that point, the creation of matter, energy, and spacetime through pure computation will move from philosophical speculation to scientific practice.